Most people who travel for a total solar eclipse expect a few minutes of darkness, but the event coming in 2027 operates on a scale that defies standard expectations. To create totality, the moon must align perfectly with the sun, casting a shadow that sweeps across the Earth at thousands of miles per hour. On August 2nd, 2027, that alignment will hold a specific path of our planet in absolute darkness for a maximum of 6 minutes and 23 seconds. In contrast, a typical total solar eclipse usually offers about 2 to 3 minutes of totality. When we plot the maximum duration of every solar eclipse this century, the 2027 event towers over every other date. Once this spike passes, we enter an 87-year gap. Humanity will not see a totality of this length again until 2114. This extreme duration makes the 2027 eclipse a generational, high-stakes astronomical phenomenon. Reaching that 6-minute peak requires a difficult geographic compromise. The path of maximum duration crosses directly through North Africa and the Middle East during the height of summer. The primary destination for observers is Luxor, Egypt, which sits at the center of the path for 6 minutes and 19 seconds. Standing among these ancient monuments provides one of the most spectacular backdrops possible for an astronomical event. But being there means enduring a severe physical trade-off: extreme, potentially dangerous summer heat. You are looking at a sun-baked environment with zero natural shade and massive global crowds competing for limited resources. This heat map tracks the path from Spain down to Somalia. Over Egypt, temperatures routinely exceed 105 degrees Fahrenheit in August. Securing the best possible view requires accepting extreme physical discomfort and complex logistical risks. Many travelers choose to avoid the Saharan heat by staying on the European edge of the path. Targeting southern Spain and Gibraltar offers established tourism infrastructure and significantly milder weather. However, this choice comes with a penalty. You sacrifice over a full minute of darkness compared to the duration available in Egypt. There is also a more severe risk: the much higher statistical probability of localized weather ruining the viewing window. Coastal microclimates shift quickly. A sudden layer of cloud cover can roll in off the ocean, making months of planning useless in minutes. Is enduring the Sahara truly worth those extra minutes? The answer lies in dark adaptation. Human eyes require several minutes of darkness to fully adjust and dilate. In a 6-minute eclipse, your eyes have time to fully adapt to see the faint outer layers of the solar corona, often invisible during shorter events. Extended duration gives astrophotographers the window to capture multi-wavelength data, revealing the sun's complex magnetic structures. NASA relies on eclipses of this length to map coronal electron temperatures and study the solar wind's acceleration. These images show how specialized filters track specific iron emissions, like Fe11, which are only observable across these long durations. By isolating these lines, researchers can identify the transition zones where solar plasma changes from a collision-dominated to a collision-less state. Viewing the plasma this way reveals how chaotic and dynamic the sun's atmosphere becomes as it reacts to magnetic fields in the vacuum of space. Those extra minutes in the desert provide the window needed to see a layer of the solar atmosphere that shorter events simply leave hidden. Choosing a path for 2027 requires an objective decision strategy. We can weigh our options on two axes: the logistical effort of the trip versus the impact of the experience itself. The European option lands in the bottom left quadrant. It works for travelers who prioritize a lower budget and milder weather, even if it means a higher risk of cloud cover. The North African option sits in the top right quadrant. This is the choice for observers who want the maximum possible duration and the clearest skies. Choosing the high-impact path requires serious logistical planning, from managing surge pricing to coordinating medical and hydration needs. No location is perfect. Every path requires paying a toll in either physical endurance or your tolerance for weather risk. The 2027 eclipse demands the rigorous preparation of a high-yield astronomical expedition. But the reward for that preparation is the ultimate visual prize in our solar system. Standing in the moon's shadow is a profound, solitary experience. Your choice of where to stand should be based strictly on your personal physical tolerance. Whether viewed from a cliff in Spain or the deep Egyptian desert, witnessing the century's longest totality delivers an unrivaled return on your investment.